In this example, we are showing the Mathews Engineering 400 megahertz FETAMP working in conjunction with a Tektronix 500 megahertz 10x probe, and we're probing a 400 megahertz RF signal with a 10 mega ohm input impedance. The amplifier, of course, is 1 mega ohm input impedance, and the 10x probe increases that by a factor of 10. This demonstration is also showing the fact that the output of the impedance of the amplifier is 50 ohms means that you can drive a long length of cable. In this case, we're driving this coil of cable, and this is useful for probing things in remote areas where it's not convenient to get the test equipment to the location where you want to probe. This is a 400 megahertz 0 dBm signal. The 10x probe has a 10 to 1 loss factor, so that's 20 dB. So on our spectrum analyzer, we're getting minus 20 dBm reading, and the response of the FETAMP is very flat. There is bandwidth typically out to about 430 megahertz or so. It is usable to much higher frequencies because the input impedance is still quite high, well above 400 megahertz. So as long as correction factors are entered for the bandwidth roll-off, it's usable as a buffer amp above that as well.